Kiddos, hope everyone's doing well. We are going to talk about, in this video, how to get the average value. And we're talking about the y value, or what I would call the height of a function. And it's a nice little application of the definite integral, which we've been talking about. First of all, this is not to be confused with average rate of change, right? That's not what we're talking about. And to find average rate of change, if you recall, of a function, we just take the slope of that secant line between those 2 points, right? We're not talking about average rate of change, however. We're talking about average value, average height of a function. So don't confuse the two. So that said, what we're going to do is we need two things, okay? Number one, we need a nice flowing continuous function, and especially on some closed interval. Okay? I'm going to find an average value of a nicely behaved function from A to B, right? So in order to do so, here's a nice little rule. So average value, or height, y value, on some closed interval, and that's going to be equal to, we're going to take the definite integral, remember, which is area, right? I'm going to take that area and I'm going to essentially divide it by the base, the length, right? So area divided by base, or length, gives you average height. So it's a nifty little application of the definite integral, right? So we take some little area, which is the definite integral, right? A to B, and we divide that by the length from A to B, and that gives us the average height, right? Which is that red line, let's say. Okay, so here's an example. It ain't so bad. So let's find the average height, or average value of, let's do the sine function on, let's go 0 to pi over 2. Okay, so let's get a little visual of what's going on. Here's part of that sine function. Here's pi over 2, here's 0. And of course that continues on ad nauseum. And that goes all the way up to 1. Okay, so what I'm going to do is to find that average y value, average height. I'm going to find the area and then divide it by the length of the interval, which is pi over 2. Okay, so here we go. Average value is 1 over the length of the interval from 0 to pi over 2. Of course, that's just pi over 2. And 1 over pi over 2 is just 2 over pi. So I'm going to change that right now. So it's 2 over pi, which is 1 over the length of the interval, 0 to pi over 2, times the definite integral value, the area under the curve being the sine function, from 0 to pi over 2. Okay? So I'm going to take that 2 over pi, and to find the definite integral, I use fundamental theorem of calculus, part 2. And the antiderivative of sine is negative cosine. I'm going to plug in a pi over 2 minus negative cosine 0. Right? And then everything get multiplied by 2 over pi at the very end. So 2 over pi is come along for the ride. Bam. Cosine of pi over 2 is 0. I don't care about that negative sign in front of it. Cosine of 0 is 1. And that leaves me with ergo, therefore, equals 2 over pi. Okay, so what that tells me is that the sine function, average value from 0 to pi over 2 is 2 over pi. How about that? Interesting. I bet you've always been wondering that. Now you got an answer. Okay, so in very simple terms, the average height, average value of a function, a nice function on a closed interval, you take the area, definite integral, and divide it by the length of the interval. Okay? Area divided by length gives you average height. Alright, here are 2 problems for you to do. For homework, number 1, average value of, let's do 2 sine x on the same interval. And how about the average value of, let's get a little crazy here, x squared plus 5x minus 3, let's say from 0 to 2. Alright, so you can give those a whirl tonight. If you got questions, let me know. Otherwise, we'll see you tomorrow.